In this video we will talk about charging a capacitor. So let me give you the answer right away. If you charge a capacitor with a current source, the capacitor charges linearly. If you charge a capacitor with a voltage source, the capacitor charges exponentially. So since I don't have a single shot capable oscilloscope, I'm gonna have to charge and discharge a capacitor repeatedly. So this is the schematic I'm gonna be using. This here is a current source, and this here is a capacitor under test. The capacitor will be charging through this resistor with constant current, and capacitor will be discharging through the same resistor through a short circuit created by this MOSFET. Current source will not affect the discharge of the capacitor because all the current from the current source will also go through the short circuit created by this MOSFET. This is the capacitor I'm going to be using for this example. It's a 0.47 microfarad capacitor, 100 volt rating. So this is the breadboard. This is the capacitor under test. This is a square wave generator. This is the power supply. And this is the waveform. This is the part of the waveform when the capacitor is charging. You can see it's a nice flat line and it's charging linearly. This part of the waveform is capacitor discharging, and it's an exponential function. Voltage on the capacitor is proportional to the amount of charge divided by capacitance. And the current is first derivative of charge with respect to time. So if the current is constant, that means we're adding some amount of charge per every millisecond. And if we do that constantly, our capacitor will charge linearly. If a capacitor is charging through a resistor in a circuit like this, that means that the current in this circuit will not be constant. It will decay. As the capacitor charges, the voltage on the capacitor rises, voltage difference on the resistor decreases, and the current through the whole circuit decreases. That means that our circuit is described by a first order differential equation. And the solution for this equation is given here. The reason we say that the capacitor charges exponentially is this exponential here, e to the minus t over rc. So this is the reason why we say it charges exponentially. So like I said, our circuit is described by a differential equation. But what is a differential equation? In a normal equation, uh, the solution for algebraic equation is a number, is just a number. But in a differential equation, the solution for the equation is a function, which means a function like this is a solution to an equation like this. In our case with the schematic I showed you, we didn't have a voltage source and our capacitor was discharging through a single resistor. And the equation for this discharging is given here. So I hope you liked my video. Please like, subscribe, and thank you for watching.